Today, I'm joined by Dr. Paul LeBlanc. Dr. LeBlanc, can you please introduce yourself just a little bit?
Hi, I'm Dr. H. Paul LeBlanc III. I'm a professor of communication at the University of Texas at San Antonio. I have been at UTSA since 2001. I teach undergraduate and graduate students. I specialize in interpersonal communication, family communication, communication education. And since 2001, I have taught an undergraduate course called Conduct of Communication Inquiry, which is essentially a research methods course. I've also taught the grad level quantitative methods course in our master's program.
It's a long time to be teaching a course. And I imagine you have seen students struggle, which probably led you to invent something, and that's the purpose of today's conversation. What is StatTree, and why did you have this idea to invent this thing?
So StatTree is a web-based tool that assists students, researchers, beginning data analysts in selecting the appropriate test for a given research question. I started this journey many years ago when I started teaching research methods for the first time. And it occurred to me in that course when I'm teaching students about stats, my experience was that stats was disconnected from the applied questions, research questions and hypotheses that occurred within my discipline. And it was a consequence of the way I was taught. For example, when I was a graduate student, which was my first exposure to, I was told, here's research methods within our discipline. Here are appropriate research questions and hypotheses. Here are the kind of stats that we use. But in order to understand what we're doing, you need to go over to the stats department and take a stats course. So I go over to the statistics department. I take a statistics course, but it wasn't applied in a way that could be understood within my discipline in terms of the kinds of questions that were asked, the types of hypotheses that were looked at. In other words, there was no context. It was all math and mathematical theory and statistical theory without any application within context. And so I struggled for the next several years of trying to figure out how to apply the statistical theory to an applied research question. When I started teaching at UTSA, I wanted to avoid that in teaching my students. And so that very first semester, I developed a statistic decision tree, which basically was a flat file. It was a PDF. It was a handout. I'd either send it to the students via email or I would print it out and give them copies of it. And the decision tree basically was set up to answer some questions. The first question was, what are you trying to do with your research question? Are you comparing groups on some variable? Or are you trying to relate variables to each other? And I used that procedure for about 13 years, right? And it eventually got more and more elaborate. As I started teaching graduate courses, I started adding things to the decision tree, including non-parametric tests, multivariate tests, because in the undergraduate class, we're basically doing descriptive statistics and bivariate statistics, and that's it. So it started to grow. This flat file started to grow for the graduate students, but it was still a flat file. In fall of 2014, I started designing my first hybrid modality course. That's a course where you meet with students face-to-face once a week, and then students have online materials that they review the rest of the week. And I sought assistance through UTSA's academic innovation team, instructional designers, with help in trying to design the materials for online use for that part of the course. During the course of that conversation with the instructional designers, one of the instructional designers, Michael Brand, says to me, well, why don't you make this decision tree, the statistics decision tree, interactive? You can do that online. I said, I have no idea how to do that. So he turned me on to a software program that had been developed by a couple of faculty members from the University of Victoria up in British Columbia called Quandary. And it was a program that they used to create HTML and Java files, which basically was designed for creating games and mazes. So in a maze, for example, a person in a maze would get to a point where they'd have to make a decision, go right or go left or go straight, right? And they could follow these various decisions till they get to the end point. And if they answered the questions appropriately, the end point would be the answer or the solution to the maze. So I used this program to construct the first working model of the statistics decision tree for the undergraduate class. And essentially, it asked a series of questions. Question number one was, what are you trying to do? What's your purpose? And that first question would have three possible answers. All I want to do is describe data. No, I want to compare groups on some variable. No, I want to relate one variable to another variable, right? Once they answer that question, the next question would be, what type of variables are we talking about? Are we talking about just categorical variables? Are we talking about continuous variables? Are we talking about a combination of categorical and continuous? What the answer to that question? Well, see, I teach in the course what variables are. So by the time students have gotten to the part in the course where they're having to make decisions about what test to run, they would already know how to define a categorical versus a continuous variable, right? So I developed this and I taught it for the first time in fall of 2015 with this interactive statistics decision tree. That's what I was calling it at the time. I came up with a new version of it for the graduate students. That was version 2. I worked up a prototype version 3 when someone in the UTSA commercialization office discovered what I was doing and said, well, we need to look at this more closely. Let's propose this for the National Science Foundation I-Corps, right? So prototype 3 was the model that I created for I-Corps. Well, as it turns out, you can't just apply to the NSF I-Corps without having some credential behind you, and they called it provenance. Essentially, what I had to do was I had to demonstrate this prototype in a regional I-Corps presentation. That happened in Houston in 2018. So in 2018, I took my small prototype to the Southwest Regional I-Corps and started the process of doing interviews with potential customers for this type of product. And I was successful with my team, which included Les Doss, who was a faculty member in the College of Business, and a graduate student by the name of David Cortez in our department. The three of us made the I-Corps team. The following year, being successful with the regional gave me provenance, so I applied for an NSF grant to go to the National I-Corps. And I was successful, went to I-Corps in Nashville in May of 2019. That grant allowed me to travel all over the country to interview potential customers. Potential customers were data analysts working in industry, their supervisors, statisticians, biostatisticians, people that were doing that type of work. So my team and I traveled all over the country. We did 128 different interviews, and we came to some conclusions about my prototype. And one of those conclusions was what I was teaching in my undergraduate class and my graduate class, which was how to do statistics using SPSS, which is a proprietary off-the-shelf program for doing stats, was insufficient for the commercialization of the product. What we discovered was that SPSS was only a very small market for this group of potential customers. We discovered that there were several other programs that were being used. And among the people that we interviewed, by far the widest used was a programming language called R. We also discovered that there were people out there that were using Stata, which is a commercial program, and SAS, which is also a commercial program. They were used less than R. Of the four, SAS was used more often than Stata and SPSS, but R was about 55% of the people that we interviewed were using R. R is open source, and it's also a programming language. So unlike SPSS, where you go through a series of menus, right? With R, you have to type up some code and then run the code in R in the R environment. So what I did after leaving I-Corps, after finishing I-Corps, I spent a couple of years, but I learned how to program in SAS, Stata, and R, and released the first version of StatTree, 4.1, which was 4.0 with the bugs worked out, in August of 2023. However, in the interim, I do recall that there were two groups in particular that we interviewed that also used Python and Julia. One group from the UCLA Medical Center at Ronald Reagan Medical Center at UCLA used Julia. I had never heard of Julia. Another group, MD Anderson in Houston, used Python. And, we asked that question during our interview. Why do y'all use Python? They said, there's nothing else on the market that's up to the scale of work that we're doing. And I said, well, what do you mean the scale of work? And they said, well, we get a terabyte of data daily. That's much larger than the data sets that we use in communication by far. Of course, they're doing health-related research, and so that's a lot of data. While according to these researchers, they have to be able to code in a way that can handle that size of data. So they're using Python. Then 2 years ago, I'm talking about StatTree to some colleagues at a conference, the International Academy of Business Disciplines. And one of the colleagues pointed out, we're teaching in Python. We're teaching people how to do stats in Python. You should consider that. So between 2023 and 2024, I went about teaching myself how to program in Python and in Julia. And this summer, I developed several programs in both Python and Julia and rolled those into the latest version of StatTree 5.0, which has several statistical tests demonstrated in Python and Julia. So now this version of StatTree, if you want to do, for example, an ANOVA, if you're a beginning student and you're using the basic side of StatTree, it'll show you how to do an ANOVA in SPSS. But there's a link at the bottom of that demonstration that says if you want to see it demonstrated in other programs, press on this link. And you press on the link and up comes a new page with buttons that say, this is how you do an ANOVA in SPSS, R, SAS, Stata, Python, and Julia. So now the latest version of StatTree allows the user to choose which programming language they want to get a demonstration in for all the various tests that I do, right, in StatTree. And there's 35 total tests in StatTree, of which 14 of them are also demonstrated, and those 35 tests are demonstrated in SPSS, SAS, Stata, and in R. 14 of those tests in StatTree version 5 are also demonstrated in Python and Julia. The interim release I'm working on right now is increasing that number of tests that are demonstrated in Python and Julia, and that's where I am right now.
So 35 tests weren't enough. You're doing more than 35 tests, and that's where you are right now. For beginning students, where and how would you suggest they get started to do their practical work, not just in your empirical methods classes, but in language and communication theory or in public relations or in any of our communication courses that need this kind of empirical research?
Right. So part of the reason why we teach undergraduate research methods, and actually it's uncommon at the undergraduate level in our discipline to have a required course in research methods, but part of the reason why we do, and it's a junior level course, is because at the senior level, when they get into public relations campaigns, right, they need to be able to analyze survey data. They have to do case studies, and case studies often require that they go and find clients for their customer, a firm that wants a PR campaign developed for them. They have to go and survey potential customers for that client, right? And they have to know how to analyze that data, right? So they take the undergraduate research methods class so that they know how to, one, construct a survey, that measures variables that are related to their research question, and then how to analyze that data, right? They need to know how to do that when they're a senior. And part of the reason why that is because when they go out into the working world and they get a job at a PR firm, guess what? PR firm's going to say, okay, I need you to go collect some data, and we need to see this data. We need it analyzed. So it's our hope that they have a leg up when they get started in their careers in terms of how to deal with data. So now at the undergraduate level, right, when we're teaching research methods, we only cover 6 different tests. We cover chi-squares, which is comparing categorical variables, basically. T-tests and ANOVAs, which are comparing continuous variables. And there are two types of t-tests. There's paired samples and independent samples. So that's 4. We're up to 4 different tests. And then relating variables. And there are 2 types of tests associated with that. Correlations, which is basically as one variable increases, the other variable increases or decreases, right? And simple linear regression, where we're not just saying that they're related to each other, but we're saying that one influences the other. So as one increases, the other one is, predicted to increase, right? That's a simple linear regression. So those are the 6 tests that we teach at the undergraduate level, right? So now on StatTree, those 6 tests are covered in the basic section. So when a student or a researcher or a data analyst sees StatTree for the first time, they have 2 options. Once they start, they have 2 options: basic and advanced. Basic is, demonstrations of those 6 tests in SPSS. Advanced is those 6 tests plus several more tests, but demonstrated in these 6 programs, not just SPSS. And that's the difference between the 2. Advanced, more detail to it, right?
Like there's more detail, the more complicated and more advanced that you go. Let's get really specific here. We have students who are doing this kind of research. Let's assume that they constructed their survey the correct way because they've taken your empirical methods course and they know how to create a good survey. What's the next step after the survey? And take us all the way to creating an audience persona so we can better understand our target audience. Because I think a lot of students might be intimidated by the statistical side and the empirical side, even if they've taken empirical methods. And I imagine StatTree can solve that problem.
Yes. So what sets StatTree apart is the motivation for creating it in the first place. And that's that when I was trained, right, stats was separate from the methods part. It wasn't applied. So in all examples, all demonstrations within StatTree, they start with these questions. What are you trying to do? What variables are you using? What kind of variables? How many variables? Those kinds of questions, right? But once they press the demonstration comes up and it goes through step by step. This test is used when you have these type and these number of variables, right? This is a survey. This survey measures these variables of this type, right? Then it shows you, okay, given your knowledge about the variables and how they're measured, right? Now we're going to demonstrate how those variables are applied within the context of a statistical test, right? In every demonstration, and there are 200 demonstrations in StatTree, every demonstration shows exactly what variables are being used, how these variables are being measured, right, within the data set. And then, only then, is it demonstrated how those variables are put into a statistical program, right, in order to run the test. Now, the other thing that sets StatTree apart is that at the end of the demonstration, the viewer, the user, is able to see how this test output looks, right? How the output looks and how it is written up in APA 7th edition style. So if they were to run a test, they get the output. Underneath the output is it written up in narrative style in the way that you might see it in a journal article, right? In addition, on the advanced side, they get to see the actual coding, the script that's used to run the test. So if they want to run the test themselves using their own variables, they can grab the script there, right? They can bring it into whatever program that they're using, that script, and then run it, right, with their variables. The script is copyable, so they can copy it from StatTree and then paste it into their program and then edit it for their variables and then run it. And then they can compare that against the output that's in StatTree to make sure their output looks correctly before they write up their narrative. Now, I've discovered that there are many websites that do this, right? But most of those websites focus on one program, right? Either SPSS or SAS, or some will do more than one. Some will do SPSS and R, or Python and R, but none of them do all 6 of them, right? Some of them that show examples of code only show examples of code, right? Don't show output. So what sets StatTree apart from everything else out on the market is that it shows it from point A to point Z every step of the way in multiple programs, right? With output, examples of how to write it up, and script that's grabbable. In that sense, StatTree is comprehensive.
And I can imagine the feeling that students will get whenever they use a product that is so comprehensive to be able to create a much better, a much more comprehensive persona for example, their public relations campaigns or their other communication campaigns activity. So a beginning student will come into StatTree with a set of data. That set of data is from their well-constructed surveys. They're going to take that data and they're going to choose a statistical test that makes sense. Can you walk us through a specific example from A to Z where we're trying to get to a persona? So let's just imagine, because I know you have a great sample data set that you use in your videos for StatTree. So let's take us through that for a public relations student, just as an example.
Okay, so in StatTree, I use the exact same data set, the same set of variables for every single test. So people can compare output of one program against an output of another program with the same exact test, or compare tests across different tests with variables that are from the same data set. That particular data set is called the Chronemics data set. It is a fake data set. It's not a real data set. It was constructed specifically for this reason, for educational reasons. But the Chronemics data set is based on an idea that individuals watch movies and TV shows with different motivations and preferences. For example, some people like to watch dramatic shows, some people like to watch action shows, and some people like to watch comedic shows, right? And also, when people watch shows, sometimes they like to watch them straight through without any interruption, and sometimes, no, they like to be able to stop it and back it up, so that they can rewatch a section if they didn't understand it or something like that. And people have different preferences for watching shows. Now, I chose this because even though it's a kind of a communication study, a general audience could understand about watching TV shows and movies. Lots of people do it, and not just in the U.S. People watch movies and TV shows worldwide. And that's kind of the purpose for doing that particular kind of a data set and survey. So let's say you have a question, and your question is, do males and females like watching the same kinds of shows? Is there a difference between males and females on watching drama shows versus action shows versus comedic shows, right? So on the survey, we ask the question, what's your gender? Male or female? On the survey, we ask the question, what do you prefer? Do you prefer drama or action or comedy? List them in order, in preference. And so you have in the data set some data that is of a certain nature, and you can run a test in order to find out if there's a difference between males and females in terms of their preference for drama or comedy or action. In StatTree, the way the survey is constructed, and they would see this, the way the survey is constructed, those two variables, gender and movie preference, are measured in a categorical fashion. And technically, the movie preference is ordinal, but it can be treated as categorical in this case. On StatTree, there's a glossary actually that describes these kinds of variables. So if you go through the series of questions and say, I've got two variables, I have, and they're both categorical, what test do I run, right? And once you answer the questions, up comes a demonstration of how to do a chi-square, right? For a basic student, right, just learning out, it's the demonstrations in SPSS. And this is chosen for a reason. SPSS is menu-driven, right? You can submit code in SPSS and it'll run the code. But if you're not a programmer and you don't know how to code, you can use a menuing system in SPSS. And I would gather most people using SPSS for the first time, for example, are strictly going through the menus. They're not putting in code, right? So the demonstration shows them exactly this is where you go in the menu. Once you have your data pulled up, this is where you go in the menu to run a chi-square. And you go through a series of menus. Then it shows you how to put the data from your data set into a dialog box. And you press a series of buttons like continue and OK and that type of stuff. And then it runs it for you in the background. In the demonstration, it shows you how it runs, and then it shows you the output. So a beginning student, right, if they know the answer to the question, what are you trying to do? You know, I'm trying to compare males against females on their preferences for movie type, right? And what kind of variables are those? Well, if they have any questions, they can go to glossary, and the glossary will show it to them, right? I have these two kinds of variables, right? And then I answer just a few more questions, and up comes a demonstration of how to do a chi-square. Now, as I said before, there's a link at the bottom. So if, for example, they're in a class and their instructor is teaching them how to program in R, right? They can click on the link on the bottom, and it actually says on the page for the demonstration, for basic demonstration, if you want to see it in SAS, Stata, R, Python, or Julia, press on this button, right? Then you press on the button and you show them how to do it in R, right? So there's always a link that brings you to the advanced site if you want to get more information.
And students can use that data to say, oh, they love, the people of this gender love my podcast format, or they love this specific kind of viewing condition. And that can help them to then paint the picture with statistics and not just looking at survey data, right? Because if you have a lot of survey data, it's very difficult to be able to say, oh, this feels like women love true crime podcasts because it looks like there's a lot of women who said yes, as opposed to an actual valid statistical test to show us that. Are there other popular statistical tests that public relations students might use to get a really good description for their persona outside of this?
Yeah, absolutely. And those are the 6 that are included in the basic, right? So chi-squares, independent sample t-test, paired sample t-test, ANOVAs, correlations, and simple linear regressions. Those are the most commonly used. And so they have options to get at that. But I want to go back to a point that you made. There is a reason why we use statistics, right? And our motivation as faculty members in the field of communication, our ultimate goal is that we want our creators of information, not only our consumers of information, but our creators of information. And our students, once they graduate in their career as communication professionals, they are creators of information, right? We want our creators of information to be credible, right? And one way of being credible is by demonstrating relationship between variables mathematically that can be replicated over and over and over again. That's as opposed to a technique that I refer to as interocular analysis. Now, that's a fancy academic term for eyeballing, right? Eyeballing is you're looking at the survey data and you're just kind of eyeballing what you think is going on there, right? That's equivalent to anecdotal evidence, which is not credible evidence, right? Credible evidence is I've got mathematical formula that demonstrates the relationship between these variables in the data set, as opposed to just eyeballing the data set and saying, this is what I think I see, right? Anybody can say that. That's anecdotal, right?
And in your experience, whenever students do use StatTree, what kind of feedback have you received from those students? Because I can imagine if I had this when I was taking empirical methods, I would be like, this is so much easier than being in the wilderness by myself, right? Having someone hold your hand and take you through the steps and ask you the questions that you need to answer in order to get that kind of capital T truth that is credible data.
Right. Well, to answer that question, I have to refer to a different clientele than undergraduate students, because most of the responses I've gotten from either graduate students or faculty, okay? Some faculty have told me, I wish I had access to this type of tool when I was a graduate student, right? You know,
I'm that person.
Graduate student telling me, man, I really need this for my thesis and my dissertation. In fact, when I first demonstrated the prototype at I-Corps, one of the things that I received much of was feedback from graduate students that were in the I-Corps program. Just like my I-Corps team, there was a technical lead or principal investigator, which was a faculty member in a university somewhere. You know, then there was a industry mentor, right, and a graduate student who served as the entrepreneurial lead. Those are the teams, the I-Corps teams. So most of the I-Corps teams, entrepreneurial leads, were graduate students working underneath a faculty member at a large academic institution, research institution. And when I did the demonstration of the prototype at I-Corps, I got inundated with comments from graduate students who are in I-Corps saying, man, I need access to this. And in the interviews that we did, we got the same kind of reaction from early career data analysts and from graduate students. Now, professional statisticians, they know all of this, so this wasn't for them. But another interesting response that we got from some of the interviews, and we interviewed statisticians, they talked about their clients. It wasn't them that needed the information, you know, explaining how this works. They know how it works, and they program in Python and R and all that kind of stuff. So they know how it works. That wasn't really the clientele. The clientele were their clients. So, for example, a biostatistician that's working at a large medical research center, right, oftentimes has as clients medical doctors. Now, if it's a medical school, those doctors are faculty members at the medical school, and they wear two hats. Hat number one is they're a medical doctor, a practicing medical doctor, right, who was trained in a medical school. But their second hat is they're a faculty member. And a faculty member at an academic institution has to publish if it's a research institution. And most medical schools are research institutions as well, right? And they have to publish. But they don't necessarily have time or inclination to do all the stats. So many of these large Research One medical schools have a cadre of biostatisticians that essentially are contracted out by the medical faculty to assist them in the analysis of their data. They don't actually analyze the data themselves. They'll write up the journal article, but they have a team of biostatisticians, statisticians and biostatisticians that will do the analysis for them, right? When we interviewed the statisticians and the biostatisticians, one of their comments was that their clients, medical faculty, don't understand the underlying statistical theory, and we have to teach them that, right? If we had a tool like StatTree that they had access to, we can say, go look at StatTree, and this will explain how these variables collected on this survey in this fashion, measured in this fashion, work with this particular test, right? In other words, it's applied. It's not just statistical theory divorced from the application of the data that's being used to test the relationship in the data.
I love how this applies to more than just one discipline. I love how it can apply to all sorts of different kinds of research that needs to employ statistical methods. Beyond the communication research and the medical research, what other fields have you seen this applied to, and what are some of the impacts that StatTree has had on those fields?
Well, impact has been very difficult for me to measure. And part of the reason why that was in the earlier version that was released to the public, 4.1, essentially it was word of mouth and social media marketing, that was sent out there for use. But the YouTube videos that are the location of the demonstrations were not public. They were unlisted in that version of StatTree, right? And when it's unlisted, Google doesn't collect analytics data on use. So I had no way of knowing how many people were viewing these videos in StatTree, nor did I have any access to analytic data for StatTree version 4.1. Version 5.0 has been out for a little over a week, so I don't have enough analytic data to show reach. But my hope is that with the new version and the meta tags that we've embedded, that essentially I embedded in the code underneath StatTree, will allow StatTree to gather analytics data, and we can see what kind of reach it has. In the meantime, I'm doing various marketing types of activities, including this podcast, as well as going through UTSA's marketing team and LinkedIn and Facebook and YouTube to send out information about this to make people aware of its existence. In LinkedIn, I've posted it and gotten several hundred impressions just the first couple of days about StatTree. And so this is part of my outreach. This podcast is part of my outreach to see if there are more people that could be made aware of the existence of this tool. This tool is free. The videos on YouTube are ad-free. It's a resource that I want to be as widely disseminated as possible. One of my peers responded to me on LinkedIn and said, yeah, I'm going to post this on the research site at my university where I teach. And so word is getting out there. And hopefully, in a couple of months, we'll see some analytics data that shows some outreach. In the meantime, I'm working on the next interim release of StatTree, which is going to include more Python and Julia coding for the additional tests that I have in StatTree that currently are not coded in Python and Julia.
So beyond the commercial audiences, you and I know the higher education audiences are going to love something that makes their life easier and makes empirical methods easier for both undergraduate students and graduate students. But I can see this apply to so many other courses beyond those pure statistics courses or those pure empirical methods courses. Have you had other kinds of feedback from faculty that you might have not expected? Has anything surprised you? Like, oh, this person is using StatTree, but I didn't make it for them, but I'm ecstatic that they're using it.
Right. I did have this is early, so I haven't received a whole lot of feedback, but one of my colleagues commented that a friend of theirs found StatTree in a Google search, was not aware that it was there, and was like, oh, wow, I can use this. And this particular person works for a very large technical company in the northwest of the United States, Silicon Valley type stuff. I won't say who because I don't have permission, but I do know that it's being noticed. Just I have no idea how much it's being noticed at this early of a stage.
And I can imagine professors who maybe don't have as strong of an empirical background. I took those classes, but it's been quite some time. Can use this to help bolster and boost their students' competencies in empirical methods. So it's not just about the tool, but it's about the making sure that you know how to use the tool, right? And using that tool to help to not only create better personas or better listener data or better YouTube audience data, but all kinds of cases can be made with these kinds of tests. Whenever you look out at the vision for the future of StatTree, can you see this becoming a standard tool? And do you think that it will always be free? Would it always be a free standard tool for students at least?
That's my intent. My intent is for it to be publicly available. I'm currently the sole proprietor of StatTree LLC. That was created for purposes of protecting the intellectual property. right? And basically that's it. I mean, it's aspects of it are copyrighted. Other aspects of it are available using a CC license, right? So for example, people can grab the code, right, and use the code. And certainly they can look at the copyrighted material to get explanation, right? But my intent is for it to be free. Although, I'm as an LLC, I am currently incurring the costs associated with producing this. It's not particularly expensive for me, but my preference is for it to maintain a free product. Now, I may discover in the analytics, in several months, that there's more work to be done. And some of the comments are, can you make this a little bit more user-friendly? I've had to teach myself programming. I've had to teach myself programming not only in these statistical programs, but also HTML and Java. And I'm not a programmer by trade. And so the user interface could probably use some work. But I'll be honest with you, that's beyond my current capabilities. And there may come a day when there is an opportunity to have a professional programmer work on the user interface to make it better and reach a wider audience. There may have to be a subscription charge in order to cover the costs of that level of programming. However, it was my intent in the original commercialization proposal, the business proposal required for the commercialization, that there would be groups who would have free access, and that would be students. Students have free access, don't have to pay for subscription. But it may be that in the future I have to charge a subscription for people that are working in the industry.
So if we were able to hire a talented UX designer, someone from the visual side of our discipline, that might lead to even more commercialization too, right? Do you see any new innovations coming down the pipeline that might impact StatTree? For example, I can see a student using StatTree with really good AI that we might have in the future, right? And even some of the models that we have now to complete their work. Can you talk a little bit about the relationship between using AI with StatTree?
Yeah, so currently people can use AI to ask the question, what kind of test do I need to run on my data? And they could do that, using whatever tools are out there for AI. However, here's a caution. Artificial intelligence uses large engines in order to pull information from all over the internet. That's how they build their information. The problem with that approach is that not all information on the internet is credible. There's a lot of not credible information on the internet, right? And one of the things that I've discovered in my own searches in order to find, solutions for these coding questions I have in these various programs is that there may be multiple sites with descriptions of how to do something or how to code something, and some of them, frankly, don't work. So here's an example. When I was in I-Corps, the I-Corps training team told us that one of the most important questions that you ask potential clients in order to determine what it is you need to do to revise your prototype, to make it better, to increase your potential market share, is to ask the question, what's your biggest pain, right? So you go to a potential client and you ask them, what's your biggest pain in trying to fix this particular problem? And when we interviewed early career data analysts, we asked them, what's your biggest pain? And they said, our biggest pain is it takes us a long time to figure out good code to run a test. And so we did follow-up questions like, well, what's a lot of time? And they said, well, for example, if I have to run a particular test, like an ANOVA, for example, and I need to find the proper code for running an ANOVA with this data set, I'll do an internet search. And it may take me 3 days or 4 days to vet all the information to get proper code that actually runs and gives me the answer that I need, right? So their biggest pain was time, right? And so, well, how do you find these answers? And their response was, we Google it, okay? but it would take them 3 to 4 days because they would have to personally vet all the information that they got in those Google searches, right, to make sure that what the information that they got was correct, right? Now, in building StatTree, and in particular, developing the code for R, SAS, Stata, Python, and Julia, I experienced that pain because I had to Google it, right? And I found out myself that when you do a search like that, there's a lot of information out there, and most of it is unhelpful. So take artificial intelligence, which uses, to comb the internet for all the information out there on how to do this, right? If they're doing that on a massive scale, and I'm only looking for one thing, and it took me days to vet all the information to get the good information out from the bad information, then you can discover just how problematic AI might be for this purpose, right? And in fact, there's some well-known YouTube physicists that talk about the problems with AI in regards to that, right? AI combs the internet for all this information, but it takes more processing that is outside the capability of AI at the time to determine what's good information versus what's bad information, right? So yeah, I would imagine, and we're learning this in academia, that students can use AI to answer certain kinds of questions, right? But we're also discovering in this process that when they have their answers generated by AI, there's still another step that has to occur, which is the human interpretation of that information that they've generated through AI to determine whether or not that information is good or bad, right? If a person relies solely on AI, they're going to be in trouble, right, in that regard, because it's not yet at that level of being able to do the type of critical analysis that's done by a human actor, right? Of course, now that human actor has to be an expert, right, because they have to be able to determine what's good information versus bad information within a particular domain, right, the domain of the expert. And when it comes to this type of information, I can see AI as being useful to get you in the ballpark, but you still have to do some critical analysis of the information generated by AI to determine whether or not it can be used.
And that critical analysis is important for the results of our tests too, right? Because a lot of times people can get in trouble for blindly accepting the data from statistical tests the same way. I know that, for example, Khan Academy has famously introduced Conmigo, which doesn't give you the answer. It just gives you hints. Like it kind of says, it looks like you're trying to solve it for ANOVA. Have you considered this? And it doesn't actually give you the answer. I can imagine with a talented UX designer and something like Conmigo where you have put in all of your answers that have been pre-vetted and you have all of that research already done in a custom GPT like that might be more useful than these kinds of error-prone large language models that are pulling from all over the internet.
Right.
That could be a way to move forward with AI for StatTree. Obviously, this is years from now, I'm sure, right? Whenever it's gotten good enough and cheap enough to where we can, integrate those sorts of things. But I really appreciate your warning us of the dangers of using these kinds of models instead of going to a trusted source like StatTree, because I know that students are often going to AI first, when in actuality, they should be going to sources like StatTree first to ask the kinds of questions that will yield the most useful results for their specific research tasks. Other than AI, are there any other features that you would like to see in the future, the near future, or the far future for StatTree?
Yeah, so currently when a person gets to the demonstration pane of StatTree, right, they get an iframe, and within that iframe is a YouTube video, right? But underneath that iframe are these buttons that they press that will pull up the either the output or the script or the transcript of the video if they want to see that. Now, all the videos are closed caption, but if they want to be able to read it all at once, and you're a faculty member too, you know that different students have different learning styles. And some of them like to see things, bit by bit. Some of them like to see it bit by bit sequentially, right? Some people like to be able to see it bit by bit, but like to be able to move back and forth. And then some people like to see it all at once, right? So they can click on the transcript, which will explain everything out one by one. But this transcript, as well as the output and the script, are all PDF files that are linked within StatTree. It pulls it up in a separate window so they can have two windows up, right? But it's still a PDF. It would be much more user-friendly, for example, if it were in its own separate box on the page so that people don't have to pull up another window with a PDF, right? Especially in terms of the code. Many of the sites, for example, that demonstrate Python and Julia code have a box where within the box there is an icon that allows you to copy and paste to your clipboard, right? So that you don't have to drag it, pull up a flat file and then drag it and then press, Control V or Control C to copy and then Control V to paste, right? You don't have to do any of that. You just press a little icon. From a user standpoint, it would be much more functional if that were to occur. But like I said, that's currently a little bit beyond my programming capability, and I would need some serious help with somebody that's good at that sort of programming to construct that. But I would like to see that in the next major release of StatTree to be
possibly coming soon. Possibly coming soon.
Okay. So another thing I'd like to share is I'm not opposed to doing the work, of finding the code, right? So like my peers that are working out there in the field that are spending 3 or 4 days having to vet the code, I've felt their pain. I've experienced that as well, right? So for my students and for any other users of StatTree, what I'm really trying to do is alleviate their pain. I'm trying to keep them from having to go through the same pain. It's all there for them, right? So in the future, if my user interface is more modern or modernized, that would reduce even more pain. Ultimately, StatTree is meant to be a tool. It's not meant to take over the job, of doing the work for people. It's supposed to teach them how to do the work themselves. That's its sole purpose, right? And actually, that question came up with some of the people that we interviewed. Well, can I dump my own data into StatTree and have it run it itself? And that's not the intent. It's intended as a teaching tool, right? So that people, if they practice it over and over again, will ultimately learn how to do it themselves. That's another beauty of StatTree. They can watch that video over and over and over again. They can go through the steps over and over and over again, so that by the time they've used it multiple times, they won't need StatTree anymore, unless they forget, and then they could go back to StatTree and then you go through the process. I've learned in my own classes that teaching something over and over again, repeating it over and over again, is a good way to learn, right? Here's an example I use in my class. There's a piece of music, a very famous piece of music that people remember, because when Beethoven wrote his Fifth, he put that theme, da, 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 in 350 measures. It's repeated over and over again so that theme will not be forgotten. So worldwide, just about everybody who's ever heard this remembers. It's the same way with research methods. You repeat the steps to analyze data. You repeat it over and over again. You repeat it often enough, then you remember it. And so in StatTree, I repeat a lot. I repeat, these are the steps that you go through. These are the questions that you have to answer. It doesn't matter if you're doing this test or that test or that test. It's the same questions. You have to ask them over and over again. In every demonstration, every single demonstration for all 35 tests that are, repeated in multiple programs, right? At the point at which the output is generated by the program, I state in the demonstration, for all statistical tests, the first thing you look for is the significance figure to determine whether or not your results mean anything at all. And this is true in every single statistical test. It doesn't matter if it's an ANOVA, if it's a multiple regression, if it's a factorial Mancova. It doesn't matter. In every statistical test, the same thing is true. The very first thing you got to look for is the significance figure. Now, that's not the only thing that needs to be reported, and it's not the most important figure, but it's the first figure. And you have to look at it because if you don't meet significance, your results don't mean anything, right? If you meet significance, they do, and you have to report them. So in every single demonstration, I repeat it over and over again. In every single demonstration, the first thing you look for with your output is your significance figure. It's a repetition, like Beethoven's Fifth.
Earlier, you mentioned pain points, and the pain points for the commercialization specifically of saving those 3 to 4 hours, and the pain points of the students of saving those 3 to 4 hours. What are some of the other pain points that StatTree solves? And why should someone rush to StatTree right now and play with the tool, with the data set? What would make them want to do that the most? What kind of feeling are they going to get when they use StatTree?
Yeah. So in our ICAR interviews, we asked people, what programs do you use, right? Some people said SAS. Some people said R. Some people said Python or whatever. It was one of those 6, right? And in many cases, particularly for the new data analysts, they've just gotten hired. They're coming from one program and having to learn a new program. So in their graduate school, for example, they had to learn programming in SAS. But then they get hired by a company and they're using R. So we also interviewed supervisors and we asked them about their pain. And they said, well, one of the pains that we feel is that when we hire a new data analyst, it takes 6 months to train them in using the program that we use, right? So, for example, one of the supervisors we interviewed said, well, we code in Python, right? But we're hiring people from schools where they're learning in R, right? And so it takes us 6 months to train them to get them up to speed in Python when they've been learning how to do R, right? So how does StatTree solve this problem? Unlike the websites that I used and received a lot of pain myself in having to investigate these, StatTree presents them in all 6 programs, but presents the exact same variables for each test across all 6 programs. So let's say, for example, a brand new data analyst is coming in, learn how to use SAS, and now needs to learn how to use R. They can go to StatTree. They can go to the demonstration of ANOVA. They can see the buttons at the bottom that say SAS and R. They can pull up SAS, look at the code. They can pull up R, look at the code. It's the exact same output because it's the exact same data using the exact same variables using the exact same data. So one of the other hallmarks of StatTree is because it does demonstrations on all 6 programs. Unlike anything else that's currently on the internet, they're able to train themselves because they're able to compare the code of one program against the code of another program on the exact same problem.
That kind of training and that kind of time saving is incredibly valuable, which makes me think that the commercialization of this will be a success, which will be a big win for students, because the more success and marketing success that this sees, the easier it will be for students to use future versions of StatTree. Dr. Paul LeBlanc, thank you so much again for joining us, for sharing the kinds of pain and the kinds of problems that are solved with StatTree. Can you tell us where we can find more information, both about you and about StatTree?
Yes. So to find out more information about me, it's very easy. You go to hpleblanc.com. That will redirect you to my faculty site at UTSA. Right? So you don't have to remember a very long URL. It's just my name, hpleblanc.com. Right?
And there's no periods or spaces. I want to make sure that our listening audience understands how to spell. Can you spell out HP for us?
Yeah. The letter H, the letter P, LEBLANC.com. hpleblanc.com.
Excellent. So that's for understanding more information about Dr. LeBlanc, his research, his work, and his passions. What about StatTree? How do we find that?
StatTree is easy to find as well. It is STAT-tree.com. StatTree site, okay, up at the top is a menu that says About and What's New, right? If you click on those links, it brings you down the page. About tells you about the development of StatTree, and it also gives you various links. So there's a link to my faculty page. through hpleblanc.com. You can get there from that location. But what's new, is right below the about, and it tells you the various stages of development. And all of those have internal links. So you can click on the links within StatTree that will bring you to other sites or other pages that will give you more background information.
I know our audience is rooting for your success, as I am, because the success of this kind of program, this kind of innovation, will reflect hours, days, years saved cumulatively across the board for anyone doing this kind of research. Thank you again.
Absolutely.